most welcome to this afternoon's DEI, Durham Energy Institute online seminar on offshore wind going global. My name is Dr. Joanna Berry, and I have the delight of being a director of Durham Energy Institute, responsible for business innovation, entrepreneurship, as well as being an associate professor at Durham University Business School. So I'm sort of pracademic, I suppose. And today I have the great delight of introducing our friend and colleague, Benj Sykes, who is going to tell you a little bit more about his role, but who stands in front of you as a long-standing member of the Durham Energy Institute Advisory Board, which is the most important part of the Energy Institute, because they give us an absolutely invaluable window on the real world, which for academics is terribly important. And these seminars are another one of those windows. So thank you very much indeed for being here to listen in. And I know that Benj is only intending to do a relatively short presentation today, a little bit about his work at Ørsted and the Danish offshore wind development scene. There's lots of news over the last 24 hours that makes this particularly exciting. And we'd love to hear your thoughts and get your questions on this. So there's an awful lot of space in today's seminar for us to hear your voices and to take note of your thoughts and opinions, which we would really appreciate. So without further ado, I shall back off. I shall hand over to Benj, and then I'll do a little bit of moderating of the Q&A when he's finished with his slides. Thank you again for being here, and Benj, over to you.
Thanks very much, Joanna, and good morning, afternoon or evening to you all. Thank you for joining. As Joanna says, I am a long-standing board member at DEI. I've been involved in the Energy Institute for about a decade now, which is pretty much the whole of the life of DEI. It's been a great journey. My own journey, for those of you who don't know me, and I seem to know quite a lot of you on this call, so that's great. I spent 20 years as a geologist in the upstream oil and gas industry. So about 12 years ago, I moved over to renewables and low carbon, and yeah, very much focused on offshore wind. So as Joanna said in her introduction, I work for a Danish company called Ørsted. It used to be called Dong Energy because we also used to be an oil and gas company. And so the company, like me, has made this transition from black to green. I'll talk about that in a moment. My role in Ørsted is quite varied. I cover everything from all of the environmental and consenting aspects, all of the sustainable ocean stuff, which is why I'm going to be talking about the going global topic in a moment. Also, all of the regulatory policy, stakeholder comms, market development, which I'll also come back to a bit later as well. So a very broad role. But alongside that, I'm chair of the Offshore Wind Industry Council, which is a group of business leaders and ministers, specifically the Minister of Energy, Kwasi Kwarteng, and also Rebecca Powell, the Environment Minister, and the Department for International Trade, where we come together to, and have been doing now for 7 years, to figure out how do we progress offshore wind in the UK. So as Joanna says, I don't have many slides. I think death by PowerPoint is probably not what we need. And I know if your life is anything like mine, you spend a lot of time watching people present and staring at a screen. So what I'd like to do is go through the topic. I've got a few thoughts to share on offshore wind going global, and a bit of background also on what's going on in the UK. But then I'd really like to open it up to questions, not just about offshore wind going global, but offshore wind more generally, the low carbon transition, and the wider energy transition in the UK and more widely. There's a lot of people on the call who I know are working in this space, as well as academics. So I hope we can have an engaging conversation, and good luck, Joanna, with trying to moderate quite so many of us. Do you want people to use the chat function?
Yes, I should have mentioned that. Thank you for picking that up. Everybody is automatically on mute at the moment, but I am keeping an eye on the chat function, and then realized I hadn't prompted you to use it. Lynn's put a little note up there as well. So please feel free to drop your questions in as they occur to you, and I will pick them up and either interrupt you, Ben, if you are at a particularly salient point, and take a breath, or make sure that I curate them and get them all in front of you towards the end of your presentation. Okay?
Great. Good. So I might as well explain the picture. Actually, love your home. That is our strapline, our motto in our company now. As I say, we transitioned from an oil and gas company to a renewables company a few years ago. We've been on an extraordinary journey, and I've been very privileged to be part of that. But the picture, some of you will recognize Copenhagen, and what you can see in the background is one of our thermal power stations just lurking at the back there. So if you're wondering, yes, we do still have thermal power, but it's biomass. It's not hydrocarbons, so no fossil fuels. I'm not going to do the big company sell. You can look us up if you want. We are available on the internet and happy to answer questions about our business. But we have three main areas, starting on the right-hand side. Markets and bioenergy is really a smaller part of our business, but it's very much an important part of our Danish heritage, providing combined heat and power plants across Denmark in the process of becoming fully powered by biomass, sustainable biomass. And I know that's an interesting topic in its own right. I'm not going to talk about sustainable biomass supply chains today, but that's a very big part of the focus for that business, is making sure that as we ramp up the switch from fossil fuels to biomass, we do that using the right kind of fuel sources so that they are properly sustainable and also properly reducing overall carbon emissions. We recently also started an onshore business. We bought an American company called Lincoln Clean Energy a couple of years ago, and that's growing very fast as well. That's principally in the US at the moment, and we have a number of projects online, 1.6 gigawatts of onshore capacity, which is by UK standards quite a lot of onshore wind, but with almost another gigawatt being built. We're also getting in now to solar and also battery storage. Hydrogen sits in the offshore business. I'll come to that now. So the main part of our business is offshore wind. We are the pioneers of offshore wind. We've been doing offshore wind now for 20 years. I'll explain some of the reasons why in a moment. But we have nearly 7 gigawatts of operating offshore wind, and that's out of a global number of about 3 times that. We're about a third of them, 30% of the global market. So a very big player in this space. And we have a huge build out plan over the next decade. So very much growing. And some of you will, no doubt, if you've walked around the coastline of the UK, will have seen some of our beautiful wind farms. And some of the bases that we have a very big base, for example, in Grimsby with 400 people working there. I shan't bore you with all of the interesting points at the bottom. Lynn, will these slides be available to people afterwards? I'm assuming they may be, so I'll make sure that they are PDF'd and made available. I guess the only really couple of interesting points. One is that we are 50% state-owned. The Danish state sold half of its ownership of us. We floated 4 years ago. Our share price has gone up 4-fold since then, and is up 30% just this year, 40%, sorry, this year. And interestingly, our market cap has now overtaken BP's. Can you believe it? So you wouldn't have thought this little renewables company will be playing on that global stage, but a combination of us going in one direction and the oil industry heading, at the moment at least, in the opposite direction has meant that we have become quite a significant player in investment terms as well as clean energy terms. This just tells our story. I won't dwell on these, but we made a very conscious decision 5 years ago that we wanted to be at the vanguard of the switch to a world that runs entirely on green energy. That's our mission, is to create that world. As you can see, the power that we supply to our customers has been cleaned up significantly from an average 400 plus grams of CO2 equivalent per kilowatt hour right down to 65, and that's going to come down further over the coming years. We've grown as a business. Our operating profit has grown hugely, and you can see 2007 we were really an oil company and a power generation company using fossil fuels, and now 94%, so almost all of our operating profit now comes from renewables, and almost all of that is offshore wind. We're also quite a profitable company. You can see our return on capital is very healthy. It's around 10%. And finally, our business is going global. So we are a very Danish company, as the name suggests. Hans Christian Ørsted, I'm sure you know, was the scientist and entrepreneur in Denmark who discovered the link between magnetism and electricity, and therefore we see him as the, if you like, the grandfather of electricity power generation using turbines. So a very apt name to have adopted for our company. But as you can see, 80% of our activities now are outside Denmark, and most of that in terms of revenue and operating profit is in the UK. It's very much the back, if you like, the cornerstone of Ørsted's business. This is just a map to show you we've got a lot of wind farms, and that's perhaps not a great surprise to some of you that know us, but we have 14 wind farms just in the UK alone, a large footprint also in Germany and Denmark, and we're rapidly building out in the eastern seaboard of the US and also around the Taiwanese coast. We've got some big projects being built. Lots of interesting stats on the right there. We've been doing this for a long time. We have a lot of turbines, around 1,500 turbines that we run, we operate. So we do everything from, we develop the projects, we build the projects, and then we operate and own them. And we, as part of that, typically sell a share off to financial investors. We built and now operate the world's biggest offshore wind farm, Hornsea 1, which you can see nestling in the middle of the North Sea. It's about 80 miles offshore, soon to be superseded by the world's biggest wind farm, Hornsea 2. And by the world's biggest, that is utility scale power generation. It's 1.4 gigawatts of power generation in one wind farm. Very impressive volumes of power coming in, over 1 million homes powered by that. So it's an interesting journey, which it's worth talking about in terms of the innovation and the research and development that's led to this industry going global. So there's three areas, and this is really to provide some context for what I'm going to talk about next, which is about how offshore wind is going global. There's three things that have really happened over the last 15 years, I would say, which have really unlocked the growth in offshore wind and made it possible for this technology to move towards being the backbone of the energy system in the UK, but ultimately, I think more globally, coastal states around the world will be looking to offshore wind as the powerhouse of their electricity systems. So there's three areas to talk about. The first one is scale, and you can see at the bottom a nice illustration of what we mean by scale. So not only have the projects grown, but so have the turbines. And if you look at what I've illustrated here at the bottom with a jumbo jet for scale, it's quite an extraordinary journey that the technology's been on. Just 18 years ago, we were putting up turbines with blades about under 40 meters long. We're now moving towards blades which provide a rotor of over 220 meters in diameter. And of course, that makes a huge difference in terms of cost effectiveness, because you need fewer foundations for each megawatt of power generation, but you also have a big higher rotor, which means you can capture more of the wind energy as it passes through the wind farm. So they become more efficient as well as more powerful. And these turbines, the ones that you see on the right, 2022, that's a 12 megawatt turbine. The one on the left, or at least our very early turbines, and we've just decommissioned our first wind farm, were 450 kilowatts. So we've gone 25 times up in power output per turbine over that period, which is a large driver of how we've got the costs down and made this a global industry. And of course, all of that's driven by innovation, not just around the turbine, but also the kinds of foundations we use. For example, we've learned how to use monopiles in bigger and bigger applications, but also electrical systems. We're just moving from AC systems. Projects are now starting to move towards direct current, high voltage DC systems, and that's a real game changer as we move our wind farms further from shore. For those of you who might be into aerodynamics, some really interesting work that's going on in terms of optimized layouts and optimized installation schedules to make sure that we make the most of the wind resource and capture that as quickly and efficiently as we can. And then the third piece, and that very much points to yesterday's news from the government, the UK government, around offshore wind, we can talk about, and that is industrializing our supply chain. So like any technology, it starts off being a bit niche and a bit cottage industry, and we are now really in the territory of an industrialized supply chain with serial fabrication of everything from foundations to turbines to cable, and also much more professionalized ways of operating and maintaining the wind farm. So it's not just about building them, it's also about how we operate them in more efficient ways. And what has that done? This is an analysis which isn't mine, isn't my company's. This is from external data looking at normalized cost of electricity from different types of technology. And as you can see, offshore wind, the dark blue over on the right, has made an extraordinary journey with costs coming down to 1/3 of where they were just 8 years ago. So in 7 years, from 2012 to 2019, we've got 2/3 of the cost of electricity out of this technology, which now means it's competing very comfortably with solar in the UK, given the levels of sunshine we have. It's not as low cost as onshore wind, but it is lower cost than burning gas or coal, a fact that perhaps not many people are aware of. And of course, onshore wind is great, and you'll have heard yesterday onshore wind is coming back in the UK and is a very important technology globally for powering economies, both developed and developing economies. The challenge for many developed countries, though, is where can you build it at scale? And I mentioned Hornsea 2 being a 1.4 gigawatt project. You certainly wouldn't get much of a welcome if you're trying to build a 1.4 gigawatt onshore project in the UK, given that it would take up 50 football pitches worth of space, and that's probably not what most people will want to have in a busy and populated island. So offshore wind, one of the lowest cost ways of generating electricity, irrespective of greenness or otherwise, but also utility scale in terms of being able to deliver significant percentages and ultimately, as you heard, very high percentages of the electricity that we consume. So that's just a bit of background on how we have, as a technology and as an industry, developed over the last couple of decades. What I want to turn to now is the question of how is offshore wind going global, and to share with you some of the work that I kicked off together with this group that I'll explain, the high-level panel, about a year and a bit ago. Very exciting piece of work that's going on, and it's a great honour to be involved in it. So this is a UN-inspired activity. You'll notice that lovely coloured logo is reminiscent of the Sustainable Development Goals logo. It's all very much connected to other initiatives around building a sustainable future for the planet that's driven through and by the UN. So the high-level panel for a sustainable ocean economy was set up in 2018, and it was set up to catalyse a really bold approach to how to ensure ocean health and wealth. There's a lot of attention turning now to sustainable oceans and healthy oceans, for very good reason. I'm sure you saw Blue Planet, many of you. We do have a real challenge as the world develops and as economies develop to make sure that we use our oceans to their maximum sustainable limit, and sustainable being key there. We mustn't jeopardize the ecological health of our oceans. We know the consequences will be dire for the planet and everyone living on it if we don't do that. So the high-level panel, catalyzed, I suppose, by Erna Solberg, the Norwegian Prime Minister. She was the initiator of this, and she brought together 14 heads of state. You can see it's a very diverse group. We've got Justin Trudeau, we've got Scott Morrison in Australia, Shinzo Abe in Japan, a very broad range of countries of all different sizes and journeys, if you like, in terms of their socioeconomic development. And they came together to look at 5 key areas, which I'll come to. One of those areas is sustainable ocean-based renewable energy. And I just wanted to slip this map in because it just shows where that wind energy is. And of course, offshore wind is not for everyone. If you're a landlocked country, clearly offshore wind is not going to be so useful for you, although you may well be taking power from offshore wind from your nearest coast through interconnected international grids, which are already there and are developing fast. But you can see around Southern Africa, for example, up the Chinese coast and East Asia, around Australia, around large parts of Southern America, the east and west coast of North America, there are some huge areas of potential for offshore wind. The warm colours are where you've got the higher winds. There are also very good winds in other parts of the world. And you might think, well, why would you want to generate lots of electricity in, for example, northern Finland, northern Norway? Well, the reason could well be hydrogen. And I'm not going to talk in depth about hydrogen today, but when you can take your electrons and do what we refer to as power to X, take your electrons and turn them into something else, that opens up a whole new area of opportunity for decarbonising the economy more widely, producing hydrogen, producing ammonia and other transportable forms of energy to take your offshore wind electricity to the places where you want power and energy. So there are 5 focus areas. I quite like this chart because it talks to what we need to do as a planet. The 56 gigatons of CO2 equivalent, that's broadly what the world's current greenhouse gas emissions stand at. I think that's 2019's number. 2020 will be an odd year, of course, because of the pandemic. But nonetheless, that is a huge challenge. And the work that's been done by the groups, including my own, working on this, is that we can achieve around 20% of that, a fifth of that reduction through these 5 areas of ocean initiative. You've got CCS, I'll go from right to left. CCS, fisheries, aquaculture, very important in terms of decarbonising food chains and food supplies. Coastal and marine ecosystems, and that's a lot of green carbon, blue carbon rather, in terms of using ecosystem-based solutions. Ocean-based transport, that won't come as a surprise, that's decarbonising global shipping. But as you can see, the lion's share of this 11.8 gigatons equivalent of abatement of greenhouse gas emissions comes from ocean-based renewable energy. And that principally is offshore wind. I'm not going to talk today about wave and tidal. I'm happy to answer questions on that. But right now, we're focused on the technology that's already able to deliver this, given the urgency of tackling climate change. So last year, the sidekick to the Norwegian Prime Minister asked if I could bring together a global consortium of businesses and other important stakeholders to look at how could ocean renewable energy go global and how could it go global fast. I pulled in Equinor as a partner in this endeavour. You'll know Equinor, they used to be Statoil, Norwegian state-owned oil company. They're pushing into renewables. I think something like 7 or 8% of their capital is now invested in renewables, the rest in oil and gas still. That probably will change quite quickly now. And so their head of renewables and I have built this coalition, everyone from turbine manufacturers to other companies who build and develop offshore wind, whether that's Mainstream Power, Shell, and some other experienced players from the industry who've come together to figure out what does it take to get offshore wind going global. We're also working with the United Nations Global Compact. That's, some of you will know them. They're a very powerful, capable organization. Also working with the World Bank and others to figure out what we can do. So what our objectives as a Oriac, the Offshore Renewable Energy Action Coalition, what a fabulous name. One to be forgotten hopefully very quickly. I'll be very happy if our name is forgotten, but our work is living its own life. So what we're working on is delivering a global vision for scaling up offshore wind. We can see it does have the potential to be the cornerstone of our clean energy future, as not just as Europe, but as the world. Not, of course, dismissing onshore wind as a really important technology as well. But we know these two together are going to be the cornerstone of the electricity system in the future. So what are we doing? We're trying to find what it is that leaders in countries that are not yet into offshore wind, what do they need to do in order to really understand and then unleash the potential of offshore energy, and particularly offshore wind? How do they assess their status? How do they understand what the potential is for their country's coastline to be used for offshore wind? How do they understand the interaction with other users of the sea? And ultimately, our plan originally, pre-COVID, was to launch our, if you like, toolbox on how to do offshore wind as a country this June at a United Nations Oceans Conference in Lisbon that was scheduled for the beginning of June. Like so much else, it's had to be shelved, and we hope we'll be able to do something in terms of a global ocean conference next year. But in the meantime, we're looking at launching our report later this year, back end of this year, as part of the high-level panel's wider launch of a number of initiatives across those 5 areas. So what are our headlines? I suppose the biggest one is that we're talking about a vision for 1,400 gigawatts of offshore wind around the world by 2050. So that's quite an ambitious number. Just bear in mind, we have about 30 at the moment in the world, maybe 35 gigawatts. So that is quite a big scale up. And it does require a lot of action and a lot of focused effort by countries, by policymakers, but also by international coalitions such as the UN to drive this forward. And of course, there's a new context I'll touch on in a minute, which is that not only is offshore wind a way to deliver sustainable, reliable electricity, but also it's an opportunity right now to drive a green recovery. And, of course, it's no surprise, having discussed this with the UK government, to hear the great news yesterday about £160 million for ports for offshore wind and the 60,000 jobs that will ultimately deliver. And of course, in parts of the country that most need economic activity right now, so not in the southeast of England. 1,400 gigawatts would power a tenth of the global electricity demand, although the difficult thing is really predicting what happens with electricity demand. We can predict how much offshore wind we could build, but it may well be that we need a lot more than that because of, as I mentioned, hydrogen and other forms of power transition and energy consumption transition, which will need more electricity, whether that's transport, whether that's heating, whether that's industry. We know that it's not just direct consumption of electricity that's going to increase electricity demand over the next 30 years. But 1,400 gigawatts is already a pretty big number for us as an industry. That would abate 3 billion tons of CO2 equivalent and also create around 20 million years of employment out to 2050. So socioeconomically very important as well. It does need a huge ramp up of activity, as I've said. Going from 30 to 1,400 will be a big challenge for the industry and for governments around the world. But so far we're off to a good start. You've seen the price point, you've heard the good news from yesterday in the UK. I think we're starting to see this industry and this technology start to be recognised for its full potential. So we'll be launching a report at the end of this year on, okay, it's great to talk about 1,400 gigawatts and we've got reasons to pick that number, but we also then go into the details of what do you need to do in terms of policy, what kind of infrastructure do you need, what kind of market frameworks. Very important factor is safety considerations. We want to be a safe industry. We don't want to be hurting people, harming people as we build out offshore wind. We also want this to be part of the just transition, so the importance of making sure that the socio-economic benefits are shared out fairly. Environmental planning is a huge one. I'm sure there'll be some questions on that, knowing who's in the audience. Offshore wind has an environmental footprint, and so it needs to be done appropriately around our seas. And of course, as well as coexisting with environment, we have to coexist with other users of the sea, whether that's fishing, whether that's shipping, whether that's radar for air defense, very important issue in Northern Europe, for example. There are a lot of issues to consider, and so one of the things our report will do is talk about how to approach that based on experience to date in Europe. And we will also touch on wave and tidal as other forms of ocean renewable energy, which in time could play a significant role. Right now, the story, as I say, is offshore wind. Of course, I finally just want to mention a few things around the pandemic. We know it has presented huge challenges for societies. You know, here we all are zooming into this. And I think, you know, if you try and take a positive out of it, it has shown us that we need to be prepared and we need to be able to deal with these existential threats to society. And of course, I'm sure many people, I've certainly heard it, that the two, this was last year, the two threats facing the planet are the next pandemic and climate change. Well, we know now what it looks like to live through a pandemic. And I think we're also starting to see what it looks like if we don't deal with climate change. And I'm really hoping that there will be, as we emerge from this pandemic in the coming months, hopefully, a real drive to tackle this next threat to our planet's future. And as I say, offshore wind will be central to delivering a green recovery. We heard the 160 million yesterday. We heard the fourfold growth in offshore wind over the next 10 years in the UK. So yeah, what we want to do as the Action Coalition is to accelerate that global take-up, providing the toolkit which governments, policymakers will need, and taking what we've done in Europe, and particularly the UK as the world leader in offshore wind, as a showcase, particularly around COP26. That's a great opportunity next November to showcase how the UK has transformed its energy system with offshore wind as an inspiration, I hope, to many countries around the world. I'll stop there and wait for some questions.
Well, there's lots of good questions coming up. I've got one for you as well, but I know that Jamie, with the excellent surname of Berry, and Abdullah and Helen have dropped a few in as well, but I'm going to take moderator's privilege and ask mine first. The skill base is going to be absolutely crucial for all of this. How are we going to upskill the workforce as part of this strategy? You need people to do things about this. I speak with a little bit of a vested interest because I'm right in the middle of creating in conjunction with the School of Engineering a Master in Energy Systems Management. Just flagging that for anyone who wants to come and do it, or send someone to come and do it.
I think what we need is more, we need more universities to take a lead, Joanna.
Of course you do. Of course you do. But on the that was on the shy bairns getting out front. But from a practical perspective, yes, we need improvements to grid infrastructure. We need a decent skill base. What do we do about that? And then I'm going to come across to some of the questions in the chat box as well.
So, I mean, skills is a huge challenge, and some of you will know in the UK, the Offshore Wind Industry Council I chaired agreed a sector deal with the UK government to build up offshore wind and scale it up in the UK. One of our commitments was to work on the skills agenda. It is a hugely important one, not simply because we need more engineers, we need more technicians, we need more people who understand how the energy system will work so that we can accommodate all of this offshore wind and the grid reliably and affordably. So I think if I'm honest, what we need to do is start with primary schools, I'm afraid. We need to get into primary schools, and we need to be talking about this exciting world of, go watch Blue Planet. You want to make a difference to the planet? Well, now's your chance. And I think one of the things that I've really seen that really struck me was people's ideas of what are appropriate careers for them are formed incredibly early in educational experience. And I've been out talking to secondary schools, and there's no doubt that we need to talk to people really early in their careers and inspire them about this, both in terms of bringing people into the sector, but also, we want a just transition as an industry. We want to make sure that we bring a truly diverse, gender diversity, ethnic and racial diversity, but also cognitive diversity. And I think, we will benefit hugely from inspiring a really broad group of people to come into this industry. Globally, it's going to be a big challenge. We do know we're picking up a lot of people from oil and gas now who are adjusting to the life without a cartel in terms of price point. But, there we go. That's just how it is. And a lot of interest in coming over to offshore wind. The offshore lifestyle, we have a lot of people that work 2 weeks on, 2 weeks off now, going out offshore for 2 weeks on a ship. So very similar lifestyles. And of course, a similar safety culture that we're generating. So we're already seeing the transition from other sectors. We'd like to do more of that. But I think in the longer term, we need to focus more on getting the younger generations more inspired about the fact that this is a great place to come and work. It's engineering may not appeal to everyone, but saving the planet hopefully does.
Yeah, absolutely. Lots of questions coming in. So thank you for your fulsome answer to that. The next few answers maybe need to be touched shortly.
Yeah.
Janie is asking about whether the number of new offshore wind farms is limited by the rate at which the infrastructure can be supplied, or is it a matter of how fast they can be built?
At the moment, I would say it's the rate at which we can build them, but I think there's a couple of constraints coming. One is grid. And by grid, I mean the physical infrastructure and also the system integration.
Right.
And therefore the power to X thing. And then the other thing that will constrain us is spatial planning and finding the right places to put it in an environmentally responsible way.
Okay, Felix, you wanted to ask a question personally. Again, because there's lots of questions, we need it snappy, please.
Okay, sorry, I'll be
It's all right, I'm not rushing you, just don't go on for too long.
Thanks for the great talk. It was really nice to have this overview. I do fieldwork in Bremerhaven, Germany, which is supposed to be the nation's center for offshore energy.
Yeah.
And they've struggled through all the changes of this nascent industry, or what it was then when I was doing fieldwork, there's still a nascent industry, with the shift from tripods to monopiles and, but kind of, I wonder whether you could report a bit on the prospects of the offshore energy industry in Germany. And the second question is, one of the stories that my informants told me often about was the thing with the porpoises and the construction of the offshore turbines, and kind of how this disturbed everything. But then they told me stories about how these offshore energy fields now actually provide ecological refuge for all kinds of species. So I wonder whether Ørsted is kind of reflecting up on there too. So it has a very positive but unintended effect. Yeah.
So your first question, Germany, I mean, you are, the second biggest market outside China after the UK. It's a huge market. It's going to grow. I think you face many of the same challenges we have. You've got the north-south transmission issue, getting all of that power to your load centers in the south of the country. You've also got the same environmental challenges, particularly in the Baltic, that we have around the UK. About making sure that we are responsible in the way that we build our offshore wind capacity. The specific thing about harbour porpoises, very important that we do build out in a way that looks after those ecosystems. I'm going straight from this to a talk about this very topic because it's so fundamental that we find the right ways to deploy offshore wind. I think if you step right back there, I think there's a question about what are our priorities as a society and how do we want to use the sea? We know the sea does not have limitless ecological headroom. We know oil and gas takes its toll. We know fishing takes its toll. We know shipping and cabling and offshore wind all have an impact. So we have to figure out what is the right way to allocate that environmental headroom so that we don't exceed what's appropriate for the environment, but we make sure society gets the most out of its oceans.
My question was the opposite, actually. So these fields are now protecting livestock.
Well, they are.
In the ocean because
that's absolutely true.
They're stopping the fish trailers, which is a great kind of achievement, unintended though. But
it is. But of course, fishermen need to earn, and fisherwomen need to earn a living as well. And so I think this comes down to hard decisions that politicians will need to figure out. You're absolutely true that from an ecological perspective, they, particularly the areas around the turbine, are turning into great refuges and also breeding grounds for a number of species, both benthic and in the water column.
Cool, thank you very much indeed. Some really interesting questions coming through from Olivia, which Olivia, if you want to ask them personally, you're very welcome to, but I'll synthesize them if not. But a quick one from Brian. Brian Matthews, who's also on our advisory board, thank the Lord. What are the plans for renewables, especially with 40 gigawatts of wind, to provide the required grid services to reduce and eventually remove the need for large conventional and nuclear plant? Or do you think there's always going to be a requirement for these from a whole systems?
So to take the last question, no, I don't think we will always need it, but I think we are we're not at the point where we have a clear plan on how to have, for example, 100% wind power. Clearly, interconnection is critical, and that's why, for example, Denmark can generate 100% of its requirements from wind power and keep the lights on because it's next to Sweden and can borrow nuclear power when the wind's not blowing. So we know that at the moment, as Brian says, we need an energy mix and we need smart ways to manage both supply and demand. And I think demand side response, power to X and interconnection are all tools which in time, and I'm not going to put a date on it, will all unlock the opportunity for much, much higher levels of penetration of non-dispatchable technologies like wind and solar.
Okay, cool. Olivia, do you want to chip in with your questions and maybe synthesize the two? That would be interesting because my colleague Olivia from Law.
Sure. Hello. I will pose my questions quickly. I'm a legal researcher, so I'm looking at some of these issues at the moment. First, floating turbine technology. There's a lot of excitement about the possibilities of floating turbines, particularly a huge potential resource far out to sea. We're talking 200 nautical miles or more in the high seas areas. My first question is it a realistic possibility that that resource can be exploited given constraints on transmitting electricity over that sort of distance?
Yes, I would say we're not there yet. We're seeing, for example, the Dogger Bank project in the North Sea is going high voltage DC. So we know DC technology for long distance transmission from marine generation is possible. It had better be because they've started building it. And I'm sure that will be a success. And you know, many of us are looking at that technology. So I think the transmission piece will be solved. There are questions though about, you know, the cost trajectory, and you'll have heard the Prime Minister wants the UK to have 1 gigawatt of floating wind by 2030. That's a huge ambition from where we are today with 6 turbines, 30 megawatts at the moment in Scotland. That's it. So a very ambitious target, and I think that will drive the cost down. It will drive the technology forward, and it may not be 200 miles offshore, but it will be in areas where the water is much deeper, fewer environmental issues potentially. Okay.
Thank you. Second question, there was a lot of discussion, certainly in the early part of the 2010s, about European states collaborating on developing shared offshore electricity grids. So combining the offshore development with grid development, which seemed an excellent idea from a sort of economic environmental efficiency perspective. But that seems to have gone a little bit, it's not so prominent now. Is that dialogue still ongoing? Is it part of Ørsted's remit?
I guess, you know, I was hoping to avoid the B word, but Brexit doesn't help that. However, there are some big initiatives in the North Sea, including the UK. I think rather than think about international grids, if you think how non-international the onshore grid is, it just tells you how the regulatory challenges, I mean, the technology is not an issue, but the regulatory challenges are, you know, the same whether you're in the sea or on land. And I think we haven't got that solved. But I do think what we call hybrid projects, where, for example, you have a wind farm that has 2 cables, one coming to the UK and one going to continental Europe, for example, that can either dispatch power one way or the other way, or just be an interconnector. Those kind of multi-use infrastructure solutions will come. There will be more integrated infrastructure, certainly. As I say, the UK's got about 11 gigawatts. We're talking about 75 to 100 gigawatts by 2050, according to the National Grid Future Electricity Scenario Study. So we know we're going to have to find smarter ways to connect to the grid and to connect to other supplies in continental Europe.
Okay, cool. We've got a couple of different types of questions, which I'm going to try and synthesize. So Bakar Bahaj and Rich Hurst and Hannah Baines all had similar questions looking at 1,400 gigawatts by 2050 is an impressive target. Has any thought been given to the waste likely to be generated and how to recycle this when decommissioning? Rich also points out bigger is better from an offshore turbine perspective, and is it likely that the materials might be changed from steel to aluminium to something less energy intensive to create, and I would suspect difficult to recycle? And Henna, our lovely PhD student, says, what are the plans for the turbines and other components after the project's lifetime? Is there a plan along the lines of reusing, recycling or upgrading components? Yes. And there's a couple of questions about geography I'm going to hit you with shortly as well.
Sure. So the answer is yes. We're doing a lot of work at looking at reducing and removing waste in terms of the recycling of our machinery when we retire a wind farm after 25, 30 years. And we've already done our first one. And of course, the same challenge exists for onshore wind as well, which has been around longer. So it's a pressing question for them as well as for offshore. I would say the biggest challenge is the blades. They're made from the high-spec materials of fiberglass, resin, and balsa wood. A bit like making a kayak in your garage. They're slightly higher tech than that, but they are very difficult to recycle. We're involved in a number of projects around the world. How do we repurpose or recycle that material? In terms of getting bigger, we will definitely be getting bigger. By the way, Ørsted intends to completely go zero carbon. So that includes all of our supply chains, all of our steel production that goes into our turbines. Everything will be carbon neutral and recycled. It's a huge challenge, but we are now actively working on it being truly carbon neutral. In terms of moving to new materials, I think blades will be the big one, because as turbines get bigger, ultimately we start to be limited by the capabilities of the blade material. And we will see what comes along. Of course, you've got carbon fiber, but it's prohibitively expensive. But I'm sure there'll be breakthroughs that will change the kind of material mix we see in our blades.
Maybe one for our soft materials students to take a look at. The lovely Tony Trapp has asked a big question. How do we get more UK engineering into offshore wind, particularly Northeast England engineering? Close to my heart. I'm a Hartlepool girl, born and brought up next to the power station. But on the other side of things geographically, Raphael has asked, what kind of challenges is the company facing in regions like Latin America to expand their power generation capacity? So a couple of geographic issues.
So yeah, so taking the first one, how do you get into offshore wind? There are a lot of opportunities, and actually in the UK right now, we are about to see an influx of new players into the market. We're going to see around 15 plus gigawatts of capacity being awarded through lease rounds. There's an auction in November with the Crown Estate, and then there's a bidding round in Scotland early next year. That's going to bring in a whole load of new companies that will be wanting to get engineering capability. So keep your eyes open for that. But more generally, I'm going to plug Joanna's course. But there are a lot of other courses in Durham and elsewhere that will give people the grounding in the fundamentals of a renewable energy system. So the engineering and the system side of that, which I think will stand anyone in good stead in terms of getting into this sector. It's a very exciting place to work.
Yeah, absolutely. Mike Cargill's just made the very sensible point, actually, that in terms of supply chain, that primary schools are always welcome specialist input with activities and resources, but they can't pay for it.
No, but I mean,
given all of the primary schools.
Primary school with some bits of straw and plasticine. I mean, not that you can go into them because of COVID, but and have a session making little wind turbines out of straws or something just to inspire, and then talk about the impact it has on the planet. So there's things we can do that only cost employees time, and I think we should all be looking at doing that a bit more. Latin America, many other markets, very challenging, simply because we know those markets are not that mature, and it's easy to forget when you sit in the UK. Developing a reliable and predictable regulatory framework in any market, never mind one that perhaps has its own socio-political challenges, it takes time and it takes energy, and that's certainly what Oriac is hoping to address.
Jean-Pierre's got an interesting historical question, but I just want to quickly come to Peter Ellis, because he's asked an interesting one. As electricity supply becomes more decarbonised, how much of a challenge is balancing the grid? What do you think the role of hydrogen will be, and will it be produced offshore?
Yes, let's see, and yes. So
you can elaborate a bit.
I think balancing the grid, as I said earlier, is one of the challenges that the energy sector is working on. I think, as I say, interconnection, supply side management, demand side management, and power to X will all be critical parts of that puzzle. I don't know exactly how that will look. I don't think anyone does. I think everybody likes to speculate. Hydrogen is the thing at the moment, isn't it? Hydrogen is what everyone's excited about. It's a bit like an attractive voice on the radio, though. Everyone likes the sound of it, but no one actually knows what it looks like. And I think one of the things that we need to do is to start really pushing through utility scale hydrogen projects to really understand the art of the possible. To start with, I think we're going to see hydrogen being substituted. Instead of having grey hydrogen, we'll have some blue hydrogen, but in my view, we need more green hydrogen, clean hydrogen from renewable electricity going into our chemical supply chains. We're already working with Phillips 66 in the Humber, for example, on that with a renewable energy powered up to 10 megawatt rather electrolyzer. So I think hydrogen is going to play a role. We don't quite know what it's going to do in terms of power generation. It's going to be great for decarbonising heat and transport, and hopefully in time power generation as well. Okay,
I think you sort of partly answered Helen Goodman's question about the culture change from black to green, so I'll leave that in the interest of time for now. But interesting historical question from Jean-Pierre, and then looking forward a little bit from Sue. From your experience, what were the political conditions that pushed the UK government to be first mover, or one of the first movers on offshore? And when looking at new markets, what political conditions do you track as metrics for a positive policy environment? And Sue unknowingly added to this, but looking at, I think she's absolutely right. If you read comments in certain newspapers and online, and despite all evidence to the contrary, there are still a lot of people who don't think offshore wind works, regardless of what the policymakers say. Yeah. So what more can the sector do to prove that it's the energy of the future, and how can it better promote?
Yeah, so I'll take the last question first. I mean, it is absolutely vital that we tell the story. I was browsing yesterday evening some of the comment sections on the BBC with the news articles around the announcement. Someone claiming costs for offshore wind that were from about 2008. And, you know, maybe that's a bit of intended bias, but I think also as an industry, we've been quite poor at telling our story, partly because it moves so fast. I mean, it was only 3 years ago that we were more than double the price we're at today. So we've been busy getting on with getting the costs down and scale up, and not necessarily going out telling our story. And I think there's a lot more we can do on that.
Can I just quickly chip in with a question from Roger Murray that might add to this bit of the conversation? Is it possible to have a technical and commercial failure with offshore wind, or are they all going to be successful? And if there are going to be failures, then what are the critical factors that determine that success or failure? Because that's an important part of the story, isn't it?
Yeah, I mean, the thing to remember about building an offshore wind farm, and I presume the question is about building it, you know, can an offshore wind farm not work?
Yes, it doesn't say, but yeah.
And of course, you have to remember, for example, if you're building Hornsea 1, the world's biggest offshore wind farm, you're actually building 174 power plants. You're not building one. So you have the benefits of repeatability and scale. So there can always be something catastrophic. You know, one of your key components, your offshore substation, maybe falls off the ship on the way out. You know, there can be extremely low risk, high impact scenarios, but it is by its nature relatively manageable risks. And of course, you know, there is still risk involved in terms of commercial risk. And I think some of the policies that we're talking about in Oriac, but also we see successfully used in the UK, are really important to de-risk the investments that we make. Of course, unlike most existing power plants, offshore wind and other renewables, all the cost is in the really in the capital up front. So you need to know you can monetize that investment. And the CFD structure we have in the UK is critical for that. So in terms of it being a failure, there are technical reasons and there are political reasons, and I think both are under control in markets. In terms of the question, how do we get up the curve with the policy in new markets? It's a really interesting question. That's what Oriac's very much focused on. And I think it's partnering with those new markets. Certainly Ørsted has had a lot of experience working in Japan, working in Taiwan, working in a number of states in the US to actually not only talk about how you build offshore wind, but also what kind of policy frameworks will inspire healthy competition, growth in supply chains, and lower costs for consumers. So I think the industry, we need to do more to go out and have those conversations with policymakers, but it's not easy and it's not quick.
Okay, I'm going to reserve the last question for the big boss, Alan Loudon, who's the chair of Durham Energy Institute Advisory Board. Ben, he wants to know what your view is on decommissioning versus repowering, given consenting challenges and the points that you made on finding space in the ocean.
So repowering is going to be big. And, you know, I don't think anyone is going to take an offshore wind farm site and just walk away from it. Particularly in the UK, we know we have long-term leases, 50+ year leases. So when our early wind farms, which maybe only have a 25-year life, are ready for decommissioning, I'm quite certain that we will see most, if not all of them, being repowered. Doesn't come without its challenges. You could maintain the overall capacity of the wind farm. For example, we have some small wind farms. They were big at the time, 90 megawatt wind farms with 30 turbines. You could replace that with 5 big turbines because the scale of these has grown so much by the time we're repowering some of those wind farms. So those come with their own environmental and consenting challenges because they're quite a lot bigger, of course, these turbines. But I think repowering is going to be key, and it will generate a lot of economic activity for the UK as well.
Brilliant. And on that lovely positive note, and in the interests of time, and because I have to go and do a podcast with Durham University Electric Motorsport, which I'm very excited about, so it's my afternoon for DEI things, I want to say, first of all, a huge thank you to Lynn and the team for pulling this all together, without whom none of this wonderful stuff would happen. And a major thank you to everybody who attended. Again, it's one of the good things that's come out of this virus is that we get so many interesting people, fascinating questions, and subjects discussed that we might not otherwise have time to. And in particular to Benj for giving us the benefit of his huge advice and experience and understanding of an increasingly important and really exciting part of the energy scene, as it were, both regionally, nationally, and globally. So thank you, Benj, for everything.
Well,
everybody,
thank
I think
you all for joining. It's been a pleasure,
been
and thank you for all the interesting questions as well.